Run, Neo, run! Long week? Ready to go home? Okay. Well, today's the last day of TechEd. I'm going to spend 75 minutes with you talking about various things, and then I'll let you go to lunch. So, without further ado, let's get started. I need to run a productivity app. Hold on. There we go. Much better. So, what we're here today to talk about is this thing called the Simple Object Access Protocol. And SOAP is a way that you can go do what you want to do with your hardware, your platform, your programming language, what have you. Hold on a second. I need to actually get some real work done. There we go. Better. Whoa, hello. I've decided you have not seen enough PowerPoints yet this week, so I've specially prepared this deck for you. Let's get going. Why XML? Let me guess. Every single talk you have been to this week has talked about the XML strategy. I'll bet there's not a single talk that you went to all week that didn't talk about XML. Is that true? How many people went to a talk that did not mention the acronym XML? What was it? It was how to put RJ45 connectors on Ethernet cables, right? Because we haven't gotten around to figuring out how to put XML into that yet. But it's coming. It's coming, I promise. XML is this thing that everyone seems to want to be involved with. What are you going to do? It's this year's Java. Thankfully, this time we're all getting along, unlike last time. So I think we finally found the solution to most problems in computer science, and it is in XML. Now, I've been spending the last 2 years of my life working in XML, and it's been really interesting for me, because I come from a normal programmer, computer science kind of a background. And a lot of the people who work in XML don't. A lot of the people who work in XML have a background in document management systems, right? If you ever hang out at an XML conference, you'll see it's very cliquey. There's the folks like most of us, I assume, which are the people who do programming and development work. And then there's the people who do document management systems. And these are the people who come from the SGML world. And it's really interesting. You know, prior to XML, those guys were just the lowest rung of the food chain. I mean, geez, those guys worked in the documentation team, right? People who work on documentation are perceived as the people who weren't smart enough to be testers, right? And so these guys are really bitter, and they're really happy now to have some, you know, their moment in the sun. And of course, what's happening? You know, all the normal CS guys are coming in, making it seem really complex because those guys made everything really, really simple. And we're coming along, making it a lot more ornate and big. And you know the software platform thing, right? We're turning it into a platform. And there's a lot of tension between the two cliques. And we'll see some examples of how that comes up when we look at the design of SOAP. This first sentence, though, says it all for me. What XML is about is adding type and structure to information. So we have information out in the file system, we have information out on the network that's coming in from a variety of sources, and we want to do something with it. And we want to be able to program against it, we want to be able to reason about it, we want to be able to write programs that do things like write other programs that do things with it. And to do that, we need some sort of structure and type system. Now, if I were a documentation guy, if I were an SGML guy, the main thing we care about in SGML is structure. So a lot of the stuff you've looked at in the world of XML comes from those guys, and it was really a lot about deciding what the parse points were in a piece of information. So we've got this blob. How do we partition it into pieces, into chunks, that we can go grab a chunk at a time? And XML certainly does a fine job of that. I'm sure many of you are out there building systems that use a lot of structured XML and use it as a better way to partition information. The problem is that only gets us so far. And for us to be able to write software, we need to be able to invent fictions, right? Because that's what programmers do. They design worlds in terms of someone else's reality, typically the platform/operating system. And they invent abstractions, which we call types, right? A customer is a fiction, right? Windows NT does not ship with the customer object built into it, right? Last time I checked, although, you know, we'll get there eventually unless Joel Klein has his way. But modulo that, you know, there's a reality which is the OS, and we go off and we design these abstractions like customers, invoices, and other problem domain specific things. And when we do that, we're defining types. Well, a long time ago, say a year ago, XML really didn't have a type system. It didn't have a good way to represent the programmatic types that we were designing our systems in such a way that we would all understand what we meant, in such a way that if I gave you a definition of a type, we would have a universal way of transmitting that, of representing that, and of understanding that. And really, XML is about unifying the structured world of documentation and the typed world of, you know, classic computer science and software engineering. You remember the 1980s? Some of you were my age, and you were working in the 1980s. In the 1980s, there was a standards body called the ISO, right, which is French for International Standards Organization. And these guys decided they wanted to do this thing called OSI, which was the Open Systems Interconnect. And representatives from this company, or from every company in the industry, both the telco industry and the computer industry, traveled throughout the globe, going to exotic locations, racking up frequent flyer miles, and spending lots of money on their company's expense reports. And what did we get out of it? After all of this standardization effort, all we got was this stupid T-shirt with a 7-layer stack on it, right? The only thing that came out of OSI was a 7-layer stack and nothing else. The protocols were completely useless. While those guys were off standardizing those protocols, the hippies in the United States came along and invented TCP/IP, and the rest is history. But that 7-layer stack acts as a great conceptual model for understanding how networking systems work. Well, it turns out that XML is reinventing a 7-layer stack. And I've got here in this slide a picture of the modern 7-layer stack that is XML. If we look at the bottom layer, it's about physical representations. That is, where is it in hardware, right? Where is the information we care about? And it's typically either in sectors on a hard drive, or it's in bit streams that are being transmitted over optical or wire transmission media. Now, of course, we don't work at that level. My guess is most of you, when you design a new application, don't say, you know, that NTFS file system, that's far too general and broad. We're going to start by writing a new file system, right? Is that correct? Am I assuming correctly? Good. Yeah, nobody does that. Everybody just goes off and uses the layer above, which is they work in terms of files, and they work in terms of file systems, and they work in terms of packets and protocols, things like TCP/IP, sockets, things of that nature. Very few people work below that level anymore. And really, that's got very little to do with XML. What XML does is it tries to take the world of the file system and the world of the network and unify them so that we have a common way of reasoning about them. And that's where layer 3 comes in. And layer 3 gives us these things called entities, which is a way of discussing a file or a network packet, right? So when I go to a URL, http:// whatever, that's an entity that I get back. And we have the ability to take a bunch of entities, glue them together, and create a document. And the document is what most of us think about in the world of XML. It's kind of the lowest level primitive most people care about. Now, above this, we want the ability to add structure, right? Rather than just having a byte streams are hard to parse. I can't write a Perl program that parses a byte stream. Right? It's just not possible, right? Or it's not practical, right? I wouldn't want to do it in VB. I wouldn't want to do it in Java. There's a myriad of languages that I don't want to work at the byte level. So XML adds structure on top of these byte arrays, which are the entities. And the structure is based on elements and on attributes. And these two things allow us to project a hierarchical model on top of the underlying storage, which is in fact disjoint from where the files come from. Right? We can build an XML document out of 7 different files and project a hierarchy that has nothing to do with where the data came from. Right? That's the idea behind XML. Now, if we look at those middle 2 layers, actually layers 3 and 4 counting up from the bottom, those are defined in a spec called XML 1.0 with an addendum called namespaces in XML. And those specifications are about how does one go from an array of bytes into these things called elements, attributes, documents, and entities. Now, if you're writing an XML parser, I suggest you go read those specifications. But I would first start by saying, don't go write another XML parser. We have plenty of them. We do not need any more. We've got more than enough to last us a lifetime. Rather, most people nowadays, just like they don't reinvent the file system, they don't reinvent the XML syntax. And they leverage an existing parser. And of course, right now, Microsoft's platform ships with an XML parser. Now, in the future, that may be broken up into multiple pieces, and they will have the XML parser company and then the rest of Microsoft. But until that happens, it's still bundled. I know it does stifle innovation, and it keeps anyone else from, wanting to write an XML parser. But that's not why I'm telling you not to write one. I'm telling you not to write one because they're grotesquely intricate and just no brain-numbing detail that you don't want to be involved with. Bottom line is we don't care about the syntax of XML. Rather, most people and most technologies and most XML specifications work in terms of a higher order abstraction called the info set. And the info set is a UML, Unified Modeling Language, version of XML. So if you read this specification, the info set, it just tells you what an XML document is. In plain, simple English, you can figure it out. You never see angle brackets, question marks, any of the funky ampersand, entity reference goo. Rather, you just see, okay, an XML document has a hierarchical model, it's got elements, it's got attributes, and the rules of what they mean are documented extremely well in that spec. Well, if your application has the primitives, element, attribute, document, and entity already, then we're done. Right? If you do not work in terms of customers, if you do not work in terms of invoices or whatever domain you happen to be working in, if all you do is XML, then we can just stop this talk right now and go get another beer. Right? But unfortunately, you folks still insist on using customers and invoices and all of those types. And so we need something beyond this. So layered above the info set is this specification called XML schemas. And XML schemas adds type to XML. So without the schema language, or something just like the schema language, we don't have any typing in XML. Rather, we just have ways of structuring and partitioning information, but we have no way of associating application-level data types with the underlying XML info set. So that's what schemas do. They allow us to define new types, which are things like customers and invoices, and describe what they will look like when they are represented in XML. And so at that level, we're working in terms of types and instances. Now, the schema language is something you're probably not used to using. In fact, it may be something you never use. Because rather, you've already got a development tool, right? You're using Visual Basic or Visual C++ or, God forbid, Java, right? Whatever. Of course, if you were using Java, you would be a Java 1. But that's not the case. You're here. So you're using VB or you're using C++ or Delphi or what have you. And you don't necessarily want to be involved in the schema language. And so we want a way to project your normal application/technology-specific types onto the schema type system, which buys us XML for your application. That's the idea of how XML works. Now, show of hands. How many of you work in Visual Basic? Be proud. This is your year to come out of the closet. Your family will still love you, right? There will be a family and friends of VB programmers parade out in front of the stadium soon. How many of you work in C++? Give us time, you'll come over. Right? Many of you are VB programmers trapped in the body of a C++ programmer, and you'll figure that out someday. We're all VB programmers at the end of the day. Great. How many of you work in some other language? Does anyone work in any other language? Okay, great. A small number. Well, let's move on. What is XML? XML is a bunch of specs. At the end of the day, unlike the old world of, say, DCOM, where it was a technology that had an implementation, XML is just a bunch of laws that everybody decides to agree upon. And these laws are managed by the World Wide Web Consortium, which is an independent, vendor-neutral body of vendors that get together and decide what XML should look like. And anybody can join. It's actually not very expensive to join. And it's pretty much universally supported throughout the industry, although there's a little bit of a breakup right now happening. If you look at the XML specifications, they come in different categories. There's something called a W3C note, which really just is a position statement written by one or more members of the body. There are requirements documents. There are working drafts in development. There are working drafts in last call, candidate recs, proposed recs, and recommendations. My God. Don, don't do a standards talk. Do you know how uncomfortable I am doing that slide? Yuck. It's like the Corba talks from the 90s. Yuck. I hated those. The only reason I have this slide here is so you can get some perspective on how stable things are, right? Unfortunately, I started doing XML in early 1998 when I started doing work on SOAP. And XML, the paint was extremely wet. Stuff was still just churning all the time. And 2 years later, it's only gotten worse. And it's very, very, very challenging to work in this field and be able to hold on and have any kind of continuity from, quarter to quarter. So the reason I have this here is to indicate what the degrees of stability are. If something is a recommendation, it's pretty much done. And you can code against it, you can build against it, you can architect against it, and it's not going to be shifting out from underneath your feet. At the opposite end of the spectrum is the note. And the note is really just a position paper, which whose details are subject to change. The ideas may stay around, but the actual details of where the semicolons go are far from done. Now, with that in mind, here are all the technologies and their dependencies. And you'll notice at the top middle of this, we have SOAP, which is what you're here to hear about. And SOAP depends directly on XML schemas. We use the XML schema type system in SOAP to allow us to go back and forth between your programmatic types in COM or VB or C++ and the XML world, which is elements and attributes and documents. So SOAP funks down to schemas, which are built in terms of the info set, which is built in terms of everything else. Great. And in terms of status, these are done. These are full recommendations. This guy right here, the schema spec, is about to go to candidate recommendation status, which means it's pretty much done. And then SOAP is, of course, a note, because it's fairly new. However, it's gotten fairly broad support, so I think the basic concepts will be there till the end, but we might change a few details along the way. So to understand SOAP, you have to understand the schema language. Without schemas, SOAP is not all that interesting. And so the idea behind the schema language is it gives us the ability to define data types that are the XML document. So we're able to project on top of elements and attributes types like customer, types like invoice, things of that nature. Schemas are almost done. As I mentioned earlier, they should probably be nailed down to a full recommendation by the end of the year. And all vendors, including Microsoft, have pledged to support this spec. So schemas are pretty much a done deal in terms of their inevitability. The question is, when will it happen? That stated, I think we're stable enough that you can build against it. I know most people I know are. So the idea in schema language is schemas are about defining types as well as binding them to names in a context. So those are three big terms. We define types. You know what types are because you have types in your programming language. Type definitions look just like any type definition you're used to. In addition to type definitions, we have these things called element declarations, which bind an element's name to a type in a context. And there are several kinds of element declarations. And if this were a schema talk, I would drill into all of the mundane details. Let it just be said, here's a schema document. The thing in green is an XML schema. And the thing in blue is an instance of that schema. So you can think of a schema like a class. It's like a class definition. And the documents are the instances of those schema types. And so notice here we have a type called Robert T, and it contains two child elements. One called count, which is of type double, another called Bobby OK, which is of type Boolean. Now the type Robert T is just a type, and that doesn't mean there's ever going to be an element named Robert T. To allow this thing to be used, we need an element declaration, which is what you see below that, that says there's an element named Bob. That's this guy right here. Well, hold on, let me do a better job. There's an element named Bob, and the type of the Bob element is Robert T. And that's how it works. And so if we look at that schema document, it corresponds to this. We look at the instance document in blue. We look at the name, which is Bob, in a particular namespace. We see that Bob is in this schema. There's an element named Bob. The type is Robert T. And in a schema-aware parser, I can walk up to that node and reflect against it, just like Java reflection or type libraries in COM. I have the ability to figure out, aha, that's not just an element named Bob. It's an element whose type is Robert T. And Robert T may be derived from other types, and it may use other types. And I can figure all that stuff out at runtime, which is very, very useful. We also have support for inheritance in schema language. We have the ability to say there's a derived type that has additional properties that are not in the base. And we have the ability to substitute derived types for base types. Here's an example of substitution. We've got a type called person, which has one element named name. That's right there. And we have a derived type called student, which extends person by extension and adds the field or property grade. So pretty straightforward. Looks a lot like any OO language you've ever used, except it's got angle brackets all over the place. And the instance document says that we have an element named Bob, and the actual type is not just a person. It's actually a student, which is substitutable for person because it's derived from person. That's the deal. Straight OO 101. Right? If you've done any work with inheritance and type and all that stuff in your language, and VB's got it and C++ has it coming out of its ears, then schemas are really just another version of what you already know. Right? You just have to get used to the syntax. All right. Enough about schemas. XML messaging and SOAP. Well, what SOAP does is two things. It gives us a way to project your technology-based types, like your VB types or your C++ types, onto schema types. That is, it defines some standard rules for mapping between the type system of your technology and the type system of schemas. And that's one of the primary benefits we get from the SOAP specification. The other thing we get from the SOAP specification is the ability to frame instances of types with well-known headers and a common extensibility model. So we have the ability to say, this is not just an instance of Bob. This is an instance of Bob that is associated with a transaction and a security context. And we can determine exactly which headers are which and which ones are safe to ignore and which ones must not be ignored or else we have a fault. So those are the two things we get from SOAP. The ability to serialize into XML using schema types, and the ability to wrap those instances, those serialized instances, in an envelope with a well-known header format so we can extend the underlying representation. SOAP was submitted to the W3C as a note a couple of months ago by Microsoft, Developmentor, IBM, Iona, Compaq, Ariba, Commerce One, a whole bunch of companies got together, HP, I forgot them. Pretty much everybody but Sun. And of course, they're at Java 1 now, coming up with JOPE instead of SOAP. why do we need this? You know, we had a perfectly good thing going with DCOM. I don't know if many of you know this. I have a custom license plate. I have a license plate on my car. I never thought I would have a custom license plate, you know, a vanity plate. In the vanity plate, in case you don't know, let me show you what it says. Good night. Look at all those windows. The license plate is, of course, I unknown. Right? My dedication to the goodness and richness of COM caused me to get a vanity plate. Well, oh, hang on a second. You can only see that in the front row. Good night. Hold on. Is that better? Good. Well, I want to get a bumper sticker. I really, really, really want to get a bumper sticker. And the bumper sticker will say this. See, COM is used for two things. COM is used to glue together a process. That is, it's a way to bring DLLs into a single process and allow them to play together nicely. It's also an IPC/networking protocol. And the good news is the same API and technology works for both, and tool set works for both the in-proc model and the DCOM model. The bad news is it's the same technology, and what is good for the goose is not necessarily good for the gander. And there have been a lot of problems with people trying to build DCOM-based applications, especially on a broad scale. Doesn't mean it's impossible, but it's very, very challenging. Let's look at some of the problems. One of the problems is DCOM is very connection-oriented. What this means is when in DCOM we call co-create instance, and it takes a long time for that first method call to get dispatched. Right? There's probably between 8 and 12 network round trips between the client and the server the first time you call co-create instance and make a method call. And if all you're doing is making a single method call, that was a lot of overhead just to get one request in. And in the load balancing scenario, this makes it really challenging to determine when to release the proxy. Because if we hold the proxy forever because it was so expensive to acquire, then what happens? We pin that client session to a particular server machine in our farm. If we release it at every method call, we die because the round trips kill us in terms of connection establishment. So one of the problems was DCOM was very connection oriented. Another problem is DCOM is not available on all platforms. DCOM is available on a variety of platforms, by the way. It's available on Windows NT Server, Workstation, Advanced Server. It's available on Windows 2000, Professional Server, Advanced Server, Windows 98, Windows 95, and I believe even now Windows CE. So that is 9. And if I were, you know, to play Bill Clinton to your Ken Starr, depends on what your definition of variety is. I would say 9 is a variety, but there are people out there that don't think so. Some people insist on running these platforms that don't begin with a W, like Solaris and Linux and things like that. And so people don't have DCOM over there, and it's really not practical to expect it on every Unix box that you're going to encounter. And there's still a few stubborn souls who have decided to stay back in the 80s with drum machines and bad haircuts, and Unix. Another problem is Corba. You know, you might want to use Corba, which is the IIOP protocol. The problem with Corba is it's very expensive, right? That it's the Unix pricing model, right? We're used as Windows developers, we're used to getting everything for free, right? We basically pay our union dues, our tariff, which is $2,500 a year for MSDN Universal, and we get everything for free, right? And you know, on the Unix platform, that's just what you pay, you know, to break the seal on the shrink wrap for the source code control system, right? And the Unix pricing model is just so impractical in today's development world. And most Corba products are still stuck back in that era. Another issue is, well, why don't I just go implement it myself, right? If DCOM the protocol or Corba the protocol are so good, why don't I just go build my own stack? That way I'm not beholden to Windows, or I'm not beholden to all these orb vendors. Well, the problem there is the protocols are extremely complex, right? They're not the kind of thing you could implement in a weekend. You know that show, what is it, Survivor? If those guys had to implement IOP to get off the island, right, no one would win the $1 million. Another problem is security, right? Getting DCOM security to work is a very, very big challenge, right? Every time you deploy a DCOM application across your enterprise, you're really playing with fire, because DCOM security is actually a very good model, but it requires a very closely administered network. The odds of, Joe Six-Pack salesman who's out on the road, his laptop dies, he goes to Fry's Electronics, buys himself a Toshiba laptop with Windows 9X, downloads your application and tries to connect to your app, and getting it to work using DCOM is very, very unlikely, right? Because DCOM works great when we have a closely administered network, but JRandom user just plugging in a Windows 9.8 box is not going to work. And then finally, we have these things called firewalls, right? There's a class of individual. You ever gone to a McDonald's? I'm sure most of you have eaten at a McDonald's at some point in your life. You ever go to McDonald's and you see the guy who's the assistant manager of McDonald's? Right? What do we know about the assistant manager of McDonald's? He doesn't have that much power in the overall scheme of things, but what power he has, he wields with a vengeance, right? God help you if you work for the assistant manager at that McDonald's, because he will make your life a living hell, right? Well, that personality type can be found out in the programming industry, right? And the system administrator exhibits very similar characteristics. The system administrator, at the end of the day, doesn't have that much power, but what power he has, he wields with a vengeance. And he is determined in his infinite wisdom that while it is completely acceptable for everyone throughout your enterprise to buy stuff on eBay, surf porno sites, and buy stuff on Amazon.com, that your line of business application actually working over the internet would probably not be a good idea. And so he installs this thing called a firewall, a Windows ISA server, right, to prevent what you want to do from happening, which is getting your application to work across your enterprise boundaries. So pretty much the world has agreed this is the way we're going to go. People have walked away from DCOM in droves. People have walked away from Corba in droves. And they have gone to this. The world's most popular application server is Apache. Apache is the way people build distributed applications on the other platform. And the second most popular application server on the planet is IIS, which is the way people build distributed applications on this platform. Both of those servers deal in a protocol known as HTTP. And HTTP is just a transfer protocol. It's got nothing to do with HTML. It does not have anything to do with HTML, in fact. Rather, it's a framing protocol that allows me to send a request and get back a response from some server out on the network. Now, HTTP was designed to be scalable. The web is the most scalable application in the world. Certainly it's one of the top 3 if you count DNS and the email system. HTTP is available on all platforms. It's a dirt simple protocol, especially the old one, HTTP 1.0. And there are very few platforms you can't get HTTP software for free typically. HTTP is a simple protocol, very little runtime support is needed, and it is barely connection oriented, right? Think load balancing, right? Unlike DCOM, where it takes 8 to 12 round trips to get your first method invoked, HTTP takes relatively few, as little as 2. And if we're using SSL, a few more, but not that many more. And the idea is it makes it very cheap to set up and tear down connections using HTTP because the protocol is fairly lightweight. The security model of HTTP is simple yet effective. People have figured out how it works. They've figured out how to make it work. And certainly, businesses rely on it. So there's a certain amount of energy and money involved in making it work. And again, HTTP is typically the only thing usable over a firewall. Let's take a look at HTTP very quickly here. HTTP is a text-based request response protocol. The first line of the request contains 3 elements. what we want to do, who we want to do it to, and what version of the protocol we're using. What we want to do is typically either post or get. They are very, very different. It's not just a matter of what string goes at the beginning. Get has a lot of characteristics which are bad for a lot of what you want to do. For example, gets are assumed to be idempotent. Do you all know what idempotent means? It means you do it multiple times, it's the same as doing it once. Kind of like saying, I love you to your spouse, or I need a raise to your boss, right? No matter how many times you say it, the effect is always the same. So gets are not very good for doing things like, please add $1,000 to my bank account, because doing it once is not the same as doing it 5 times. So that is why we have post. And post is the way most e-commerce applications that use HTTP are built, because post is assumed to be non-idempotent, right? That is, doing it twice is different from doing it once. And all of the infrastructure of the internet knows that with a get, it's safe to replay it. And with a post, it's not safe to replay it. In fact, we can only play it once. The first line of the response tells us what happened. So if you've ever used COM, you know that there's an H result that you get back from a method call. Well, similarly, in HTTP, we get back a status code telling us whether or not we were able to actually dispatch the call. And the number we're looking for is 200. When we get that, we know life is good. Everything after the first line of this text file that we're transmitting are headers, which are just ways that we can control the delivery of the message. And the payload and the headers are delimited using a single blank line. Remember, this is a text-based format. So there's an empty carriage return line feed sequence that delimits the headers of the messages from the bodies. Here are some examples. The top left shows you a get. It says we're going to go get, we're sending a get message rather to bar foo.text, and we're using HTTP 1.1. A post looks similar. The difference is it might have some headers like content type and content length telling us what we're actually sending, followed by the GUI, the actual data. Right? In this case, we're sending the string, hello world. I'm sorry, goodbye world. The thing on the right is the response. This is what we get back from the server. And in this case, we got back 200, OK. And we got back 12 bytes of text plain format. And it says hello world. Pretty simple, straightforward, ready to go. Why do we use XML for SOAP? Because it's trendy, because everyone's using it, because it's a very reasonable way to go. One of the interesting things about XML is there is no API mandated for it. There is really no precedent that I can think of for a widely accepted internet class protocol that mandated an API. Right? Think about it. TCP/IP does not mandate an API. Now, there's a few out there that you could use, like sockets, and there's a few others actually. But there's no enforcement of those APIs. You can use whatever programming style you want. HTTP is another example. DNS is another example, right? XML is the greatest example of all, because XML is producing tons of different programmatic styles for getting to it. Things like the SAX API or the DOM API. Now there's a few others that are in the pipeline, right? So there's no hard-coded way to program this stuff. Yet we can all understand what it is and how to deal with it. So what SOAP does is it codifies how to send XML messages both within HTTP messages and other arbitrary format messages. So SOAP is about taking XML and transmitting it from point A to point B. And again, if we go back to the documentation SGML head versus the software head, the SGML guys were used to having files in the file system that lived forever. Right? And this is one of the key weirdnesses of XML messaging, is that the old school was an XML document was this thing that lived forever, had a well-known name, you could walk up to it and always get it. The world of XML messaging is no. Documents are transient little tsetse flies that only live for a moment in time and are transmitted from point A to point B and then disposed of. You can never go get them again. And what SOAP does is it codifies how to do this both over HTTP and over arbitrary transports. This type system of XML of SOAP is XML schemas, as we talked about earlier. And if you want to know what SOAP is like, it's a lot more like Corba than it is like DCOM. Right? A lot of the early critics of SOAP, before they became endorsers of SOAP, used to say, oh, it's just DCOM done in XML. No, it's not. It's Corba done in XML. Right? If you really want to know the truth, it's so much closer to Corba than it is to DCOM, it's not even funny. It's ironic, who one of the original authors was. SOAP was designed to make porting to other platforms extremely simple. When we worked on the spec for SOAP, the goal was a competent programmer who's used to working with HTTP already, so he's used to working in ASP or something like ASP, should be able to read the SOAP spec and within about an hour get a SOAP client and server up and running in their programming tools of choice. And I know that's been pretty much people's experience. Folks who read the spec, consume it, understand it, go off, they can implement a system using SOAP without any external support other than what they're already using, off-the-shelf components, in less than an hour. SOAP philosophy is to first invent no new technology. The SOAP spec is already too long. Right? We were way too verbose. There were too many authors. We could never agree on how to shorten things up. But the basic ideas of SOAP could be written down in 5 pages pretty completely. And instead, the spec is about 20 pages. Nonetheless, it's still pretty small. Why is it so small? Because we don't really invent much. We needed a type system for SOAP. So we pulled one off the shelf. It was called XML schemas. We needed an extensibility model so that we could add annotations to headers, to packets, to messages, to be able to distinguish what was mandatory and what was optional. So we pulled something else that was off the shelf called HTTP Extension Framework and just put angle brackets around it. We never mandate an API, so you can program this however you want. I think ASP is a great way to program SOAP, as is JSP. SOAP doesn't require you to have an orb sitting around, so you don't need DCOM or a Corba orb to make this work. We also don't mandate that you've got a web server. You don't need Apache or IIS. Right? You can just bootstrap your own HTTP daemon. Great example of that would be the Apache Tomcat project. We do not mandate a programming model, but a lot of them are pretty easy to infer. Remember when I started the talk, I talked about the SGML guys and the software guys, that they're really two at odds classes of people that are involved in XML. And with SOAP, what we tried really hard to do was walk the tightrope between the documentation heads and the software heads. And when we look at an XML message that's done in SOAP, it's not purely the most efficient format. Right? If all we cared about was software generating these things, that is, having programs emit them and programs consume them, we would have made a lot of decisions somewhat differently. But because we wanted these things to be human readable and understandable, we compromised enough so that it looks like a normal XML document like you would read in a Simon St. Laurent book. Right? He's one of the most popular XML authors out there. But at the same time, there is a type and there's a type system and a type hierarchy that makes sense. So we try to balance between the XML and the type worlds. We also try to balance between loosely coupled and tightly coupled communication models. That is, what kind of assumptions can we make about the connectivity of the other side, and what kinds of protocols are we going to accept? Additionally, we had to balance between loosely coupled type systems, like JavaScript, and tightly coupled type systems, like C++. And so we made the type system, we use schemas in such a way that if you aren't into types, if you're not into schemas, if all you care about is structured data, you can still live in a SOAP world and be quite happy. So there are two aspects to SOAP, a serialization format and an extensibility model for applying it to HTTP. The serialized format can be summarized in one sentence. Just use elements. Let me bring up a text file and we'll talk about that. Let's say that someone gave me the following UDT in Visual Basic. Hold on, I have to remember how to type VB. Okay. Is that correct? How about now? No? You know, one of the best features of VB7 is you can use the semicolon. Of course, they have this special character you have to type before it. It's that one. Okay. So there's our type, person. Now, two ways to represent this. So let's say I had one. So dim Don as person. Don.name equals DonBox. Don.age equals 25. Okay, and how would we represent that in XML? Well, there's two ways. One way to do it would be to say, that's one way to do it. Another equally reasonable way to do it would be this, though. Agreed? Both of those convey the same information, right? They're both in an element named person, and they both have two properties, if you will, name and age. Which one's better? Depends on who you talk to, right? Well, with SOAP, what we did was we said, look, it makes no sense to allow people to do this arbitrarily, right? Because one might say, well, I'll put the name as an element and the age as an attribute, right? And we would have chaos. So SOAP encoding rules can be summarized in one sentence. Just use elements. So in SOAP, we take the stance that all content, all user information that we care about must be in this form. And that attributes are only used for structural metadata. That is, for binding together things, for annotating things. But the actual values that we are conveying in these messages are always encoded in elements. And we call that encoding style element normal form. The other one is called attribute normal form. And so one of the primary benefits we get from SOAP, I know it sounds like not that big of a deal, but believe me, it's a huge deal, is we say, look, we're going to break the tie, and we're always going to use elements. And if you don't like it, don't use SOAP. And if you really don't like it and you want to use SOAP, we have a back door where you can turn this off. But in general, we assume the world will use the SOAP this way. Cool. Now, the way to look at the SOAP specification is we take a couple of existing specs, which we had nothing to do with, XML 1.0 and the schema language, and we layer the SOAP encoding rules of using element normal form, which is defined in section 5 of the SOAP spec. On top of that, we have a framing protocol called SOAP::envelope, which allows us to have extensibility points in the format. We then talk about how to take a method call in Corbo or COM or C++ or whatever language you're working in and map it to a request type and a response type. And we have some well-known rules for doing that. And then finally, we have SOAP over HTTP. Right? After we've done all of this XML munging, we then have the mapping so that we know how to do it over HTTP. And again, that's there so we all do it the same way. Make sense? If you don't like the HTTP mapping, don't use it. If you want to send SOAP requests over MSMQ, I think that's a great idea. You can use everything except the outer layer of this onion. Right? And we designed the spec in such a way that it's ordered in the order of precedence. So if you don't really care about the HTTP stuff, just ignore that part of the spec. It's totally sanctioned. People are doing it all over the place. If you go to the Apache.org website and grab the SOAP implementation that was worked on by IBM, their implementation works with both HTTP and with SMTP, which is the mail protocol. Right? Totally legal, totally sanctioned, totally fine. Good idea to do it that way. So it's a modular specification. Here's the big switch that gets you into SOAP programming. There are really three ways to view a SOAP call. One way to look at SOAP is that it's really just another RPC protocol. Right? We've had a lot of RPC protocols over the years, and yes, SOAP could be viewed as yet another one. However, we designed it in such a way that SOAP could be used as an arbitrary messaging protocol. That is, we don't force you to have a request followed by a response. If you want to have 3 requests followed by a response, that's totally cool. If you want to have no requests and only responses, fine. We have a simple messaging format that allows you to build the messaging patterns you need using technologies like MSMQ, IBM MQ series, and what have you. The most interesting, to me lately at least, is that one way to view SOAP is as XSLT with a longer wire. That is, we send a request document into a transform which does some processing and produces a result document as the output. Right? And anyone who's ever used XSLT knows there are 3 documents involved. The source document, followed by the transform document, followed by the response document, the result document. SOAP could be viewed as an XSLT over HTTP. And in fact, I've got a live SOAP server over at Developmentor, which is written in 100% pure XSLT. We'll step through that a little bit later here. Right? So there's no need to actually write VB or ASP code. We can actually just define what the output looks like in terms of the input, which is really all a function ever does anyway. Of course, if you want to come up with a 4th programming model that's even funkier than that, go for it. Right? We designed the protocol to be very simple, minimal, and flexible for people to go out and innovate with. So here are the 3 views of a SOAP call. We're used to, as COM programmers and VB programmers and C++ programmers, of thinking of methods like function calls. And that is, we have an object reference which we invoke a method on, and we pass some parameters to that method. Well, the way this works in memory, as most of you know, is there's a stack, and we pass a few things onto the stack, including our this pointer, the object reference, and the return address, followed by the input parameters. There we go. Another way to view it, though, is to say, let's look at the input parameters and define them as a structure. That is, let's just make a type out of the request. Let's make a second type out of the response. And let's hoist the request and response to first-class status. And that's exactly how RPC works. When you define an interface in VB or in IDL, the COM runtime goes off and synthesizes 2 types per method. One for the request, one for the response. And the plumbing of the marshalling layer inside the proxy takes the stack frame and packs it into that request type and then serializes that. A similar process happens for the response. Well, in SOAP, we make that explicit. We say, yeah, for a method, there are going to be 2 types, one for the request, one for the response, and we can program in terms of those if that's the way we want to do it. And of course, those types are an abstract type. We make them concrete by mapping them to the XML schema language. And so that Java class definition that you see in the middle has been mapped to the XML schema language over in the right. And on the wire, we deal exclusively in XML schema types, but we fully expect people to map them to their programmatic type systems like Visual Basic and C++ in order to be able to write programs against them. But the beauty of this is, because we all agree on XML and XML schemas, I can write my program in C++, you can write your program in Perl, we can live on whatever platform, and we're not going to impose our programming sensibilities on other people. Right? Not everybody wants to use the programming language you do unless it's Visual Basic. Right? So it doesn't make sense to impose programming languages on anyone. So if we look at a SOAP message, the SOAP message is framed in this thing called a SOAP envelope. And the envelope just tells us this is a SOAP message, and the content will be in a well-known place, and the extensions will be in another well-known place, and we'll know how to read them. That's all the envelope does. It's actually a fairly minor benefit, but it's a real benefit, because it allows us to look at an XML document and say, aha, that's a SOAP message. I can send that down the SOAP plumbing, and if it's not, I'll send it somewhere else, because it doesn't do SOAP. Inside the envelope, in fact, I'll tell you what, let's do this interactively. So to do one of these guys, we simply say envelope and the namespace that we use is this. Perfect. So this says we have a SOAP message, and inside of it will be at least the following. So the real information goes here. Everything goes in the body of the envelope. And we might have, before this, that. And this is where we put the extensions to the message. This is where we would say put a serialized transaction identifier for doing transactional RPC kinds of applications like you're used to doing with COM. This might be where we put security information like a digital signature, which is protecting the body. This might be where we put locale information so we know the message came from a French speaker as opposed to an English speaker. All the context information that we want to flow from the sender to the receiver, which doesn't imply anything about the interface that we're or the method that we're invoking. That stuff goes in the header. The body is where we put the actual content, which has, the targeted meaning. And what goes inside the body is an instance of some type. Like that. And there's a SOAP message. It's almost 100% compliant. We only have to do one more thing, which is deal with this. What do you think the likelihood is of multiple organizations having a data type called person? It's pretty high. Well, just because the string name of that tag is person, we can't really infer much about it unless we know whose definition of person we're talking about, right? You might think age means chronological age, from date of birth. Maybe someone else's definition of the age property is age of that record in the database in milliseconds, right? And those are going to look extremely different. And there's no way we could ever figure out what they mean unless we know whose definition it is, and we've somehow communicated those definitions between the human beings that are writing the software. So this guy also needs a little bit of extra work. We need an XML namespace around this attribute, or this element rather, to indicate whose version of person we're talking about. And the easiest way to mark these guys up is to run this tool. Let me go grab a UUID. And there we go. So let me put a prefix on it. There we go. So now what I've done is I've qualified the definition of person to be my version of person. And when I tell you about it, I'll give you a schema document with that UUID, with that identifier. And now we all know that when we see that element, it's not just any old person, and we can't really decide what that means. Rather, we know that's the version of person that Don Box designed, in front of a bunch of people at TechEd. And I can tell you what it means, and we can all pass them around, and we all can agree on what the syntax and semantics of the person are when he's transmitted. Cool. So here's a couple of examples. The thing on the left is a SOAP request. The thing on the right is a SOAP response. Those are complete requests and complete responses along with the HTTP headers. And in this case, what we're doing is we're invoking a method called add in some interface, passing two arguments, 24 and 53.2. And we're getting back a response that contains the sum, which is 77.2. So what we did was we took the method and we broke it into pieces. Let me give you an example of that. Got it? This is a simple method, a simple interface with one method called add. that takes two request parameters, which are arg1 and arg2, and one response parameter, which is sum. This is equivalent in the SOAP world to doing this. And let me just ask you a question. Looking at that method definition, is it any different from the previous one? So we have two data types, add and add response. And when we invoke this second version of the add method, we pass the add request as the input, and we get back an add response. Does everyone in the room see? It's a syntactic variation on exactly what we had before. In both cases, we call a method whose name is add, and we pass two longs named arg1 and arg2. And we get back a single long, which is called sum. And it's really just a syntactic sugaring whether we pass them as individual parameters or whether we pass them in a structure. That at the end of the day, it looks exactly the same on the stack, independent of which form we use. And we achieve the same functionality. Well, with SOAP, what we do is we take these two types and we translate them to XML schema using the standard Section 5 encoding rules. And then when we send these things in HTTP or SOAP messages, we simply are sending instances of those schema types. So if you look here, that's an instance of that add type that we just defined in that pseudo IDL. And here's an instance of the add response type, which again we've just defined in the SOAP in the pseudo IDL. Cool. Section 5 gives us well-defined rules for encoding. Here are some examples you can read in your copious free time. I'm sure you were thrilled to see them go by. There's some well-known headers that we can put on here. But I think what we need to do now is write a little bit of code, because I'm personally sick of looking at PowerPoints. Let me bring up the primary development tool for SOAP. Actually, let me make a new directory. So all we need to do SOAP applications is a text editor. So what I'm going to do is write a file. Larger font I am hearing. Hold on. Better? Okay. Hold on. I can't use Emacs in that mode, sorry. Let me use an editor I can get around in better then. Okay. So let me save this file. Okay, so where we go, we don't need that thing. So what do we do? Response.content type equals text/XML. sending an XML document, so we put an XML declaration in front of it. And now we're ready to go. So what do we want to do? Well, we need a SOAP envelope, so env:\envelope, XML_NS, SOAP envelope. Okay. And we're going to need another thing, XML_NS:iCalculator equals http://foo.com/iCalc. And let's close that off. Let's make sure it's working. localhost/TechEd/live/soap.asp. Okay, so that's working. Let me put the fonts in cheap seat mode. It's a little bit better at least. What do we know we need in a SOAP response? We need a body. And now we need to define a method. Well, let's do iCalculator add, because it's the easiest one, and we can hack it up in 30 seconds. So what we're going to do is say there's a instance of the type iCalculator add. And inside of it, it's going to have two fields. It's going to have one field, rather, called sum. And the sum will be what? 33. We'll just hard code it for a second, then I'll put in the dynamic value. So there we go. Schwing. That thing's working. You know, we've got a SOAP response. I've got a little command line doohickey here called client.js, which takes 3 parameters. It takes the URL. Hold on, I'm going to put the font in a compromise size so I can actually use the shell. There. That's a little bit better for me, at least. So I'll do a client.js, http://whack, localhost, whack, TechEd, live, soap.asp. And then I pass 2 numbers, 3 and 4. And I got back the number 33, right, which is down there in the bottom. If you look in the left-hand side, it's there, 33. Fantastic. Now, that's kind of useless, right? What we need to do is pull the SOAP request out of the HTTP request, parse it, and dynamically generate the response. So let's do that very quickly. Well, first thing we need to do is parse the XML that comes in the request. So var document equals new ActiveX object msxml2.dom document. If, oh, and then hold on, document.setProperty selection language XPath. Now, if document.load request, what does that do? What that does is it takes the request object from ASP, which contains the XML that's being sent downstream, parses it as XML, and allows me to walk across it as if it's an object model. So I've now got the XML in memory from the request, and the next thing I need to do is pull out A and B. So, hold on, I need a couple of variables here. Var A equals 0, var B equals 0. So A equals document dot select single node A dot text. B equals something that looks remarkably similar. And away we go. So I've now pulled A and B, which are the 2 numbers I'm going to add, out of the request message. All I need to do now is do that. Y'all got it? So let's try it now. So I'll run our little client app again. Remember, I'm adding the numbers 3 and 4. Your prediction for the response will be 34. You are exactly correct. What happened? Type. What happened was I'm using a parser that doesn't know about the type because MSXML doesn't support schema types yet. It will soon. Pretty much nobody supports them yet. So I have to know a priori that those guys are longs and convert them to numbers. So let me just do that conversion very quickly. A equals new number A. B equals new number B. Right? That's just the JavaScript way of converting it to an int, or to a double, actually. And now, when I run the client app again, you'll see that 3 plus 4 is, in fact, equal to 7. Make sense? Now, that's one way to write a server. Another way to write it is using XSLT. Let me bring open a file here for you. So this file that I just opened, which I'll, let me put a line break or two in here so it'll be easier for us all to read. There we go. That's all I need. This is an XSLT transform that takes as input the same request as my ASP program did and says, look, if the request contains an envelope followed by a body with an iCalculator:add inside of it, then please run this template rule. That is, please make the response document what I have put in here. Remember, it's likely I want to support a bunch of different typed methods on my servers. So to do that, I can just clone this thing using editor inheritance, which is a vStudio 6 feature, and change it to, say, subtract. And change the expression to be number A minus number B. Right now I've got two methods on my server. And if we look at this, here's the match rule for add. And all we're doing is emitting the envelope, emitting the body, emitting the iCalc response. And inside of the sum, we're using an XSL instruction called value of, which says take the A and B out of the current context, which are child elements, and convert them to numbers and then subtract them or add them, and then emit that as a string. So what you're seeing there is the moral equivalent of the ASP angle bracket percent equals. That's what XSLT value of does. And it takes some arbitrary expression and converts it to a string and emits it, just like the ASP version does. If I want to program against this one, I'll just change the URL in my request. So now, instead of going to live/soap.asp, I'll go to soap.xslt. And notice I got the same answer a hell of a lot faster. The reason it came back a hell of a lot faster is that XSLT is running in ISAPI, not ASP, so we're not paying the cost of the ASP runtime. Additionally, the XSLT engine is all caching, so all of the definitions have been pre-parsed, everything's ready to go, and it's a fairly quick turnaround to convert it back to the response document. So that's a completely reasonable way to write SOAP servers, just like ASP is. Right? And there are other ways. You can do all kinds of implementation techniques. I should charge my battery or switch to output. You know, hold on. We now know how long a ThinkPad battery lasts. There we go. Sorry about that. So to wrap up, XML layers structure and type over information. The schema language is where we get the type system. And what SOAP does is it says, OK, we're going to come up with ways of mapping VB types to SOAP types, to schema types, and transmit those using messaging. Right? And the idea is it's such a simple protocol that you can implement it yourself without any assistance from any vendor. right? It takes me, 5 minutes to hack up a SOAP server that's 100% compliant with the spec. We wrote the rules to be easy to conform to, not hard to conform to. So you can download the spec from the World Wide Web Consortium website, w3.org/tr. And I really encourage you to go out and play with this stuff. It's a real great opportunity to build the application exactly the way you want, not the way some vendor has decided it should be. So anyway, I'd like to thank you for coming. Go have some lunch, and if you come to my ComTalk later, I'll see you there. If not, bye-bye.